You may have learned that leaves are green because they're full of a green molecule called chlorophyll. It's the reason for the greenness of plants, from moss green moss to grass green grass to evergreen evergreens. And the reason chlorophyll is so incredibly popular, showing up in nearly every plant on Earth, is that it's good at soaking up sunlight. The more light a plant gets, the more energy it has to make sugar and grow tulips and kumquats and do all the other things plants do. But wait a second, doesn't the fact that chlorophyll is green mean that it's actually bad at absorbing green light? I mean, sunlight is composed of the whole rainbow of colors, each a separate wavelength, and the colors we see when we look at a leaf are the wavelengths that leaf isn't absorbing. That is, they're the ones that bounce off the leaf and reach our eyes. Chlorophyll is great at absorbing reds and blues, but if it were really awesome, wouldn't it absorb all colors of light, green included, giving us a world full of black moss and black grass and ever-black trees? So why aren't leaves black? And since they apparently don't have to be black, what's stopping them from being red or blue instead? Is green just nature's favorite color, or is there something special about those wavelengths of light? The short answer is that we don't know for sure. Some scientists speculate it's serendipity that plants today are green. Long ago, Earth's oceans were filled with purple single-celled organisms called archaea. Being purple, they absorbed green light and let red and blue pass through. The theory is that this minus green light was the only source of solar energy in the deep water below, so bacteria living there got really good at absorbing everything else but green. And the molecule that did the light absorbing? Chlorophyll. Maybe. What we do know is that chlorophyll, as wasteful as its failure to absorb green light may be, turned out to have other biochemical advantages over the purple competition. And perhaps as a result of this ancient biological rivalry, the plant world today is green and not purple or red or blue. Of course, you might still wonder why plants didn't develop black leaves once they emerged from the depths. I mean, they changed a lot of other things going from bacteria to mighty redwood. Well, maybe it's simply that nature isn't about perfection, and life doesn't need flawless black to get by, just good enough green. Or maybe plants were even more clever and turned the weakness of chlorophyll into a strength. We don't know exactly where this molecule came from, or why it was green. I mean, black would clearly be better at absorbing all colors of light. However, the fact that almost all plants on Earth are still using chlorophyll's recipe must mean there's more to it than meets the eye. Plants need light-absorbing molecules like chlorophyll to do just two things. 1, capture the sun's energy, and 2, transfer that energy to other components of the leaf so they have fuel to make sugar. It turns out that having light-absorbing molecules that are bad at absorbing certain wavelengths of light isn't actually that big of a deal, because molecules like chlorophyll aren't just on the surface of a leaf, but instead are spread in layers throughout. That gives the leaf ample opportunity to absorb every photon of light passing through. For example, even though molecules of chlorophyll are abysmal at absorbing green light, this layered arrangement allows a leaf to capture up to 80% of the green light that hits it. In fact, if a leaf were to absorb all that green light right at the surface, it could be at risk of taking in too much energy too quickly and suffering the botanical equivalent of sunburn. Another handy thing about capturing the energy in a spread-out fashion is that, once absorbed, the energy is already spread out. No need to transport it throughout the leaf. And that's good because now the real work is about to begin, using the sun's energy to cook up sugar from water and carbon dioxide. And this is where chlorophyll really shines. Other cellular kitchens, like those in purple bacteria, can make sugar too, but not quite as well as the green ones. That's because the green sugar-making machinery is both smaller and thus less energy-intensive to build, and at the same time has a more powerful system for using light energy. It can combine the energy captured from 2 photons of light together to fuel a supersized sugar synthesis. So, among the light-harvesting systems that did evolve, the green recipe was superior to the purple one. And we can see the outcome of that competition every day all around us. I mean, green photosynthesis accounts for more than 99.9% of the natural productivity on Earth. But did the physics and chemistry of green make that outcome inevitable, or did it just turn out that way? Is there a planet somewhere out there in our galaxy dominated by purple plants? We don't know, but what we do know is that here on Earth, chlorophyll's strengths far outweigh its distaste for greens. And for our planet at least, maybe that's not such a bad thing.